Hi, ladies and gentlemen, this is Mr. Green, and this is the last lesson in Unit 4. You'll be taking the unit test here pretty quickly, but we're in Unit 4 of Algebra 1, and this lesson deals with solving a very specific type of problem called a cost problem. Now, we've looked at cost problems before, but a lot of cost problems involve the mix of different products together with different prices, and you use that as the problem. So in this particular situation, you have 2 pounds of organic tea that cost $6.75. Okay, how many pounds do you have? You got 2 pounds that cost $6.75. A is mixed. You're mixing this with some generic tea. The generic tea cost $3.25 a pound. How many pounds of generic tea should be used to make a new tea mixture that costs $4.65 a pound? Now, there's some variables missing here. I'm going to use X to be the pounds of the generic tea because that's what they want to know is how many pounds of generic tea are we going to have to mix, right? So X is the pounds of generic tea. So first of all, 2 pounds times 675. Okay, I got that. Plus, we're mixing it together. We're going to add it in there. X pounds at 325. We don't know how many pounds we're going to be using. How many pounds am I going to wind up with? I'm going to wind up with X plus 2. And I want that to cost 465. I can now use distributive property and a few other things here, and I wind up with these two adding together to give me 1350 plus 325x is equal to, well, 465x plus 2 times 6 is 930. Looking at this problem, 325 is smaller than 465. I'm going to subtract the 325 from both sides. 325 minus 325. And what I wind up with is 140x plus 930. So I'm going to subtract the 9.30 from both sides minus 9.30. And I got 4.20 is equal to 1.4x. I'm going to divide by 1.4 or multiply times the reciprocal of 1.4, and I wind up with x is equal to 3. That means 3 pounds of the generic tea mixed with the 2 pounds of the organic tea, and you'll wind up with a total of 5 pounds. But this is what the question is asking, 3 pounds of the generic tea. Okay? Let's try another one here. Here we've got cherries, chocolates, and nuts being mixed together to make something. Okay? A cherry chocolate nut bar or something like that. And they want to create an equation from this. They're telling you the cherries cost $6 per amount, whatever it is, and that the chocolate costs $3 for that same amount. Okay? And the nuts, well, we don't know how many nuts we're going to use. That's the whole question. But we want the whole thing to be 5 pounds or 5 units. So what we're going to do is we're going to take 5 minus this 2x to wind up with how many nuts we're going to use. And the nuts cost $5, so 5 times that. And we want the whole thing to be $23.50. So I'm going to be able to add 6x plus 3x plus 5 times 5 minus 2x to equal $23.50. We can use this formula that we just came up with right here and combine some like terms and do the distributive property. Well, distributive property first. That'd be 25 and that'd be minus 10x. So 6x plus 3x is 9x. Minus 10x gives you minus 1x. Plus 25 equals 2350. Okay? Well, I'm going to subtract the 25 from both sides. I'm going to get minus x is equal to minus 1.5. So, multiplying by negative 1 on both sides times negative 1 on both sides, and negative 1 times negative 1 on both sides. I wind up with x is equal to 1.5. What does that tell me? That means I need 1.5 pounds of cherries, 1.5 pounds of chocolate, and 5 minus 2 times 1.5. Well, 2 times 1.5 is 3. 5 minus 3 is 2. Yeah, 2. So I want 2 pounds of nuts. Mixing that all together, we would get 5 pounds here. Okay? Multiplying it over here, we're going to get $23.50. And so our answer is we would need 1.5 pounds of cherries and 1.5 pounds of nuts and 2 pounds of, 1.5 pounds of cherries, 1.5 pounds of chocolate, and 2 pounds of nuts. Right there. Cool? Cool. Okay. That's the way these problems are put together. They could be as difficult as that one there, or as simple as this one. Alyssa's mixing 6 liters of cranberry juice into 14, there's another number, 14 liters of apple juice. So we got 6 and we got 14. And they're liters. And had 49% sugar. The apple juice had 49% sugar. The cranberry mixture is 59% sugar. The cran apple mixture is 59% sugar. What percent was in the cranberry juice? Percent in the cranberry juice. Well, this is simple. I'm going to do 6, and x is going to be that percentage. We don't know what percentage it is. Plus 14 times 0.49. Where'd that come from? The 49 was right here. 49% sugar. And when I add those together, 6 and 14 is going to give me 20 times 0.59. Why am I multiplying it times 59? Because that cran apple mixture was 59% sugar, 0.59. Now I'm going to multiply the numbers together here real quickly. 6x plus, and I can do this on a calculator and get 6.86 is equal to 11.8. Subtracting the 6.86 from both sides, and I will get that 6x is equal to 4.94. Multiply times 1/6 or divide by 6, and I wind up with x is equal to 0.8233333333, or 82 1/3% sugar. That's what the question was asking. What was the percent sugar of the cranberry juice? That's what the answer is, 82 1/3%. Okay? Hopefully you're seeing that through this stuff we have been able to set up these type of problems, have variables on both sides sometimes, and be able to solve the problems. Like this one here, we had variables on both sides of the equation that we were able to solve it a little bit. Okay? We've been able to set up word problems, and you're getting to the point you can solve some real world type situation problems that you might be running into. Okay, questions that come up, bring them to tutoring, talk to me in Class Connect. I look forward to seeing you.